focus on spread. Okay, so the two common one are range, and then you have interquartile range. Okay, so first, range is defined as maximum value minus the minimum value. Okay, the simplest measure, but ignores everything in the middle. So for example, if you have data which is given in this format, you have this one as the maximum and this one as the minimum. So you subtract 4 from 21, right? And you get this value of 17. That will be defined as the range for this data set. Now, the second measure of spread is known as IQR in short, but it is interquartile range. Okay, it essentially measures the spread of the 50% of the data points. So again, let's say if you have a data which has been sorted here, after sorting you get this, right? Now you can partition this data set in such a way that you have a lower 25% here, higher upper 25% here after sorting. So again, sorting is required after sorting, and you have this middle portion. This is middle portion of the 50% of the data, and you take the minimum and maximum value difference in this middle portion, and that will be termed as interquartile range. So for example, if you see here, right, like again, somewhere if you're using this data set, the interquartile range, right, could be somewhere in between this, right? This is like the, I think, let me erase this just to clarify, right? This will be the middle portion, upper 25%. This is the lower 25%. And so if you take this value, 7.5 minus 2.5, that will give me the range of the middle 50%. So the range of the middle 50% is known as interquartile range. Okay. And why do we want to use IQR? Like median, the IQR also ignores the outliers. Typically, the outliers might be on the left-hand side or the right-hand side. So if you just focus on the middle 50% of the data and you compute measures on that or metrics on that, that will give you more reliable measures than which takes the whole data into account. So again, this is second measure which is typically used, which is known as IQR or interquartile range. Okay, now other measures of spreads. Other measures of spreads are, standard deviation and variance. Both of them are correlated to each other, right? And again, you can derive standard deviation from variance. Okay, and the way to calculate is this equation. Before I go into this, I want to just ask one question. How many of you know the concept of variance and standard deviation or have come across this concept in any of the math classes that you have taken so far in your high school? We have one.
I have.
Good. Two of them. Okay, so this concept has been covered, so that's good to know. Okay, so again, the way to compute is, let's say if your data is given, first thing that you do is compute the mean of this data, right? So how do you compute the mean of this data? You add them up, 2 plus 4 plus 6 plus 8, and you divide them by the number of data points, which is 4. And if you do that, 20 divided by 4, so the mean will come out to be 5. Now what you do is you compute this individual sum square from the data minus the mean. So 2 minus mu is 2 minus 5. Okay, we square this term, and that becomes right here. Now 4, similarly 4 minus 5 square, we do that. Then 6 minus 5 square, we do that. And 8 minus 5 square, we do that. So it's basically the individual data subtracted from the mean and then squaring that up and adding all of them on the numerator is what is here. And then divided by the number of data point 4, which is given here. So if you do this, this is 3 square, this is 1 square, this is 1 square, and this is 3 square. So 9 plus 9 plus 1 plus 1. So this again, I can write it 9. This will be 9. This will be 1, 1, and this will be 9. So 10 plus 10, 20 divided by 4. The variance comes out to be 5. Right? So this is known as variance, or this is denoted by this symbol, which is sigma squared. Now, the standard deviation is essentially the square root of variance. Okay, since the variance is denoted by sigma squared, it's just a symbol. You take a square root of variance, and that gives you sigma, or the value of the standard deviation. So the standard deviation in this case, the example that we are carrying, is root over 5. Okay, so once we do this, sigma is the root over 5, so that will be nearly equal to 2.24. Okay, again, so this is how you compute the variance, and from variance you can compute the standard deviation by taking the square root of that, and that is, a very good measure of spread. Okay, now what does standard deviation tell you? It tells you the typical distance a point is from a mean, right? So if you have, the data set is given, what is the typical distance uh, from the mean for all the data set that is there? Okay, here is an example where you have low standard deviation, where the data is clustered tightly around the center. So this is the data set, and number of frequency, most of the data set are very, very close to the mean. Whereas here is another data set, which is like data sets are far away, spread far away from the mean. Okay, so if that is the case, that if the data points themselves are far away from the mean, then the standard deviation is typically going to be larger. Whereas a lot of data points clustered close to the mean, then that will have a lower standard deviation. So this is a qualitative aspect that you should always keep in mind. Okay, most data point close to mean, low standard deviation. Data points far from the mean, you fall into this high standard deviation case, right? So both variance and standard deviation measures how spread is out, how spread the data is. Standard deviation is easier to interpret. Why? Because it is in the same unit as the data. So if this is centimeters, after taking the square roots, the sigma will be also in centimeters. Whereas the variance, since we are squaring here, the unit of the variance is going to be in centimeter squares. So typically SD is preferred and easier also to interpret. Okay. Now you should not focus on calculating the standard deviation using the equation, because that's going to take a lot of time. You should qualitatively understand that the standard deviation is a measure of spread. And given the four data set, which one is going to have a more spread? Sometimes a good proxy of standard deviation is range. Which has the highest range? That is typically going to have a higher standard deviation too. Good, very good. So what I'm saying is a good proxy, not necessarily all the time. Good proxy of standard deviation is range. And again, I say it with a caveat, not necessarily all the times, but so the data set which will have a high range will have also high standard deviation. What is the range for here? 4. What is the range here? 16. What is the range here? 0. What is the range here? 8. That's the range, right? So which one has the highest range? This one. So there is a high likely that it will also have the highest standard deviation. Make sense? So that's one way to qualitatively answer. So this you do not need to do it. But having said that, this is not true in all the cases. Okay. So one thing that we can do in order to solve this problem quickly, because if you start doing standard deviation, you can see the standard deviation calculation is involved, in the sense it's time taking, not involved in the sense it's complex. It takes more time. So using Desmos for this kind of problem might be also the most accurate way to do this. And we will go through that later on, right? So use Desmos, calculate the standard deviation for this data set, this data set, this data set, and that will give you the most reliable answer, and it will be also even faster. Okay. So again, when the standard deviation comes into the picture, the best way to solve those problems is probably Desmos. And again, we will do those Desmos problems later on the statistics, once we covered all the things. We have done some of the problems using Desmos, but any standard deviation problem, immediately use Desmos.